Let us continue with our discussion on linear programming, and we are now in second part of our review, that is recall on graphing system of linear inequalities. For this one, let us graph the system 3x plus y is greater than 4 and 2x minus 3y is less than or equal to negative 9. Graphing system of linear inequalities uses the same method in solving system of linear equations by graphing method. So we will graph the two inequalities separately, identifying their solution, and the solution to our system of linear inequalities will be the common solution to the two inequalities, or we say the intersection of the solutions to the two inequalities in the system. Let us start with the first inequality, that is 3x plus y is greater than 4. The method that we're going to use here is the slope-intercept method. So translating the first inequality in the slope-intercept form, we'll have y is greater than negative 3x plus 4. We got that by using the addition property of inequality, adding the negative of 3x to both sides of the inequality. So in here we have y-intercept as equal to 4 and the slope is negative 3, or we have negative 3 over 1. Locating the points on the line, we have 0, 4 because the y-intercept is at 4. And then to locate the second point, we use the slope equal to negative 3 over 1. So that means we move from our y-intercept 3 units down and then 1 unit to the right. That gives us our second point. In this inequality, you will notice that we do not have the equal symbol. So the line that we're going to use is a broken line. This now divides the plane into two half planes, and we're going to identify the solutions to this inequality by using our test point, the origin, at 0, 0. So we substitute 0 to x and to y in our original inequality. That gives us 3 times 0 plus 0 is greater than 4. Simplifying, we get a false statement, which is 0 is greater than 4. So that means the solution to our inequality is to the right of our broken line, and we show that by shading that region. Okay, let us proceed to the next inequality, that is 2x minus 3y is less than or equal to negative 9. So using the same method, we translate this into y equals mx plus b, or the slope-intercept form. We get y is greater than or equal to 2/3 x plus 3. Again, we got that by API, addition property of inequality, adding 3y to both sides, and then dividing all terms by 3. Okay? So that is y is greater than or equal to 2/3 x plus 3. So from here we get this, the y-intercept as equal to 3. So we can plot that at 0, 3, the first point in our inequality. The slope is 2/3, so from our y-intercept, we move 2 units going up and 3 units going to the right because the slope is positive. So that gives us the second point on the line for our second inequality. And since this inequality has an equal sign or equal symbol in its inequality, so we use a solid line. Again, to identify the solution to this inequality, we shade from our true statement by using a test point. So at test point 0, 0, we have from the original inequality, 2 times 0 minus 3 times 0 is less than or equal to negative 9. Then simplifying, we have 0 is less than or equal to negative 9, which is a false statement again. So we shade that portion on the rectangular coordinate system, which does not include the test point used, 0, 0. So we now have the two inequalities and their solution. So the solution to the system is that region common to both solutions, or the intersection of the two solutions. Let us shade that now using another color. And what is left in our screen is the solution to the system of linear inequalities, which means all points included in the shaded region satisfies or gives true statement to both inequalities in our system. Okay, that wraps up our review in linear, recalling the systems of